All right, welcome back. Now this is assignment 2's redo of the video. So I've kind of cleaned up a little bit of the data because we found a problem with it later on, which will happen. So continuing on from last time, where we had the metadata and we had the field obs, we had the problems with the experiment name primarily, and HWAM. Now this time we needed to grab some more variables. Maybe you would want to do something with irrigation total, or get some soil P, soil K, something maybe you cross tabs of some kind, and so that's something you might want to do. So let's go ahead. This time we've got more variables from the metadata. We're going to create our M, our F, and get my head out of the way. Put that over here for now. We're going to make our data table. We have a problem. ext group by, yep, see, that's what I said in the video, in the redo of video 1. I often will have a second variable where I actually track the differences, because you can always, sometimes things happen. In case though, going ahead and cleaning this up. So making my data table, summarize, and my summarize all in the same option. So we are grouping by these items and summarizing. This is very, very similar to what you're doing with the pivot table in Excel. So here's my data. So it's found mean and yield standard deviation for all of these three dimensions: Athens, dry 17, and fallow. Now, again, these are different based off of year, so mostly. So that maybe isn't all that useful. Maybe we want to just know the yield by mean yield by location. So dat. So here's our mean yield and standard deviation by location. And then maybe we want to know it by previous type, previous land cover type. So here we have yield by that. You're going to want these to be discrete, which the soil P and soil K are. If you're wanting to play around with that, I'm going to warn you that there is a problem with the soil P and soil K in that let me open up my metadata, very high. There are some observations that have an extra space in front of very high. So that will be a problem you'll have to deal with, similar to like I did with the string, or with the string trim function. If you want to look at mean yields by soil P and soil K. And you'll also want to keep in mind that the irrigation total right now is a character, and it really ought to be an integer or a number. So you'll have to do the same thing I did down here with HWAM, create it as numeric. So if you want to do any more with that. This has been kind of a quick and I guess if you have other kinds of explorations you want to do, by all means, just tell the story. Until next week.
All right, welcome back. You've made it to assignment 2. And in this assignment, what we're looking at is the mean and standard deviation. we're looking at measures of central tendency and dispersion. And we're going to look at it, same data, so we can kind of just pick up where you left off for assignment 2. This is one of the cool things about using our RStudio online like this, or Posit Cloud, is that maybe you've been away for a week and you're back and this is still here. So it's not like if you restart your computer you lose it. So the first thing you're probably going to want to do is, let's create a new script. And after we create the script, we've got our data. The thing is we don't have all the variables we need. All right, so in the new file here, let's go ahead and save that. Homework assignment 2. We're going to start with this note that is continued from assignment 1. We've still got our metadata. This is one of the reasons you don't want to change files or tables, so that you can kind of revisit them. And so you want to do your analysis on a copy of a table. At least that's what I tend to think to do. We're not going to need M anymore, and we're not going to need F anymore, so we can use these same ones and it'll just write over the top of them. That's fine. Let's see, so we decided we needed experiment year, experiment name, local ID, and then we needed ICPCR. Okay, that's there. It prompted us for that. And we need IR underscore T. Okay, irrigation. Soil P. Soil K. Okay, and then we're gonna again take the distinct and we'll do that. Worth looking. So last time we were able to kind of ignore this. So here we have dry 16, GRF. Looks like there's possibly some difference, mostly in planting date. It's all sorghum as previous crop. Population was the same. Irrigation is the same. Soil name's the same. Okay. It will be interesting to check, and this will check for us actually while we do it, that this distinct will now consider all of these variables instead of just the ones we had initially. So if there's any variation, we could have some interesting, like, so if the irrigation or soil or P or soil K, if it differs by experiment year, experiment name, and local ID, and then we could have some interesting joining of the tables, and where we have to really dig in a little deeper even. But let's see if we can avoid that. Okay, so we find our M, find our RP, and let's join. Look here. Yeah, we got multiple matches. We're gonna have to dig in. I'm going to pause right quick and so that I can get out the spreadsheet. And so what we are looking at here, our message here, it says row 14 of X matches multiple rows in Y. Recall X is F, our field observations, Y is our M, is our meta data. And so row 14 matches multiple rows in Y. That's a problem, because that means that there is more than one of the experiments or metadata experiment that we're looking at, and we can narrow that down by that's not row 14. This is row 14. Copy metadata. Paste. We have these two rows here. Now, they're both, let's look at the differences. They have a different harvest date. They have different previous crops. And you have different irrigation totals. So I mean, these are different. These are different. We need to figure out why they're different. And I'm bringing you along on this because this is this process, because this is going to happen every time you try to do something. Okay, so what else can we do to match metadata and field obs? Let's look at, I wonder if there's a function for overlapping names. All right, so Googling function to find overlapping column names. So first hit Stack Overflow, that looks like promising. Okay, let's scroll down here, and it says intersect open parentheses names. The names function will list the names, and between data frame 1 and then there's another names data frame 2 function. So an intersect function will find the common names between them. So that sounds like a good thing to try. Let's go back to posit, and we'll go up to our script. And we want metadata. We'll go ahead and do that data frame 2 because that's just to be consistent with our X and our Y. Data frame 1. All right, what kinds of names do we have? Okay, so what about, we have experiment year, CRID, HCOM, and EXNAME. CRID looks like the column, the crop code. All of those are going to be soybeans no matter what, because it's soybean data. So that's probably not the ticket. What about HCOM? And again, harvest grain, probably not the ticket. We've got our experiment name and our experiment year. have to look deeper. So after diving into this a little more, I'm not seeing a way without contacting them to determine which field observation is with which of those two duplicates. So what we're going to do for the purposes of the class, we'll use the many-to-many, and hopefully that's not going to be too bad. I think if I were doing this in a production environment for a client, I would do the calculations once with a many-to-many like this, and then once where I selected manually, put them all in from the first row of the first site, metadata site, and another time with them all in the whatever calculations I want to do, and the second one, and see what kind of difference it makes, and then disclose that to the client, because I'm not seeing much of a way around it right now. So that would probably be my approach, again, if I was working for a client on this. But it's classroom, so we're able to skip some steps like that. So we're going to set many-to-many, and if you run that and you get that, what you find is that it alternates. So every row of the field obs, the first one that matched SY16GRF got the one with corn and medium soil P and very high soil K. And then the next match got the field that was sorghum and got a little less irrigation, had high soil P. I don't anticipate there being a whole lot of difference. I don't anticipate it mattering a whole lot, but I mean, again, it might. I don't want to muddy the water in class with this, but again, this is something that happens with real data. You're going to have problems that you have to figure out how to talk through, and how you want to explain that to your client. So that's going to be the approach that we take to keep things simple. But again, I think I would do the three runs and see if it mattered. If it did matter, then probably would be looking into more a simulation approach where I was running this, finding these calculations, finding these through sampling and then resampling, and doing this over and over again until I kind of had an idea of what the distribution looks like. So hopefully it doesn't matter that much. But we've got our data now, and it has all of our columns that we were wondering about. And then what do we want to do? We wanted to find what we're going to do now is we need to find our mean and standard deviation. And you could calculate, you could go mean and do DAT, $, and what are we supposed to define find the mean of each of those, so of yield. So that was HWAM. Remember, we made that HWAM 2, so let's use that one. It's actually numeric. Run that. Run that. Oh, well, we can't. We gotta drop. Let's look in the help. NARM, that's what we're looking for. We want to remove those. I mean, no point in taking the mean of a yield to include the NAs. 53. Okay, cool. Maybe not what we're looking for though. Let's do summarize. Now, I think I've trained R in. It has actually the U.S. spelling or the English or the British spelling. You can go either direction on that. So let's actually delete that. And we want to use summarize. And let's look at the help on that. What do you say? All right, so we're going to use the summarize function. If we look at the data here, or the help here in the dplyr, or the tidyverse, it is, we can do a few things. We could do our grouping in the summarize. We could do that by. However, those are experimental, which generally want to avoid unless you're okay with experimental functions. So what we're going to do is we're going to do this a little more deliberately. So summarize, we'll do mean underscore yield, and that's going to equal mean and that is our HWAM 2 and our standard deviation. What was that again? Up here, helpful functions, SD. Actually, you know what? I should do this differently because we're going to end up taking multiple yields or multiple means and standard deviations, and it would be helpful to have them grouped by the variable instead of the operation. So I forgot to include na.rm equals true in that one. Na equals true, and we're going to say yield mean. So let's do that. Let's see what we have. So by saving it, by doing that, now dat is my summary data frame, and that's okay. Our yield mean is 53.83, and our yield standard deviation is 14.90. So on average, our yields were 14 bushels to the acre, more or less, than 53 bushels to the acre. Okay, so that's interesting. Now we need to group this though. We want to group this. Now let's say we go and slide down the table here, or the help file here. We see that we can group by as something before our operation. So let's group by. Group by, and we'll do local local ID ex name and ICPCR. Now let's look back at the help right quick. Did I need to put quotation marks? Group by does not say we do. Let's see if it works. Sometimes it does, sometimes it doesn't. All right. Okay. So again, local ID is not found. Let's look at that. Oh, it was supposed to be. Let's do that again. Okay. So back to DAT. And now we see that our yield by this much more expressive total here. Now, here we have a whole bunch of additional SY17 Athens numbers, which we go up here to Athens SY17. So this right here, a bunch of different numbers there. It looks like they treated that differently. So maybe every experiment had that. Let's go back and let's drop the summary statement and take a look. Look at that. And we're going to go filter SY17 Ath. Okay. So let's look at that. Now let's look at the metadata go back to the metadata. Experiment name, filter, SY17 Ath. Only includes two of those, 226, and they're all the same, 226.18. Again, we have very similar, very similar matches. These that weren't 226.18 did not find a match. Once again, this is probably something that you would have to contact them about if you were really diving into this. What we are going to do is trim this out so that these are not there. That will have to wait. All right, so the approach on this that we're going to take is one that I definitely hoped to not have to deal with for you guys. We're going to have to dive into the world of strings. And the simplest string package, or the best one, is part of the tidyverse, so you're still there. So if you look at regular expressions in Stringer, it will kind of walk you through this. This is probably still not going to be clear. It's something you have to play with a lot, I think, to really understand. But what we have is a way of detecting. So what we're going to tell it is, we're going to go up here to this line here. I'm saying mutate, creating another variable so that I can compare it. If else, then one of the stringer functions is str detect, underscore detect. So then we're going to have it look in the experiment name, and we're going to tell it to find SY17ATH. So it's going to match that. Now, it doesn't matter that there's stuff beyond that. Well, we could definitely write it so that, but all we care about is matching that beginning. So then we're going to, if that's the case, then just put in SY17ATH. If that's not the case, that's what the if else is telling us, then whatever was in the experiment name, X name, put there. Okay, so that's what that one's doing. And metadata. Metadata, if you recall, had one, it was like 228 something. 228.18, I think it was. And then field observation was the one that had all of those different ones. So yeah, we can go to metadata, it's 226.18. Okay. And the field data was different. So what we'll do here is we'll match that, and then in the field obs, we're going to do the same thing. Just strip off the extra, and if you do that, then you have F, and you see how all these SY17 ath becomes just SY17 ath. So then when we match, so if we run this and we merge them, and then we should end up with the data table we can work with. So again, let's delete that and summarize yield by those groups. HYM2 is not found. There we go. My apologies. I commented that out and didn't get rid of the comment. All right, so dat. Okay, so we got our NAs induced by coercion. That happened in the as numeric operation, and then we're grouping, and then we're summarizing. So let's look at DAT. Okay, so if the local ID is Athens, and the experiment name is dry17ath, and the ICP CR is fallow, then the mean yield was 33 with a standard deviation of 5.71. Now that shouldn't have been that way, and those shouldn't be that way. So let's look into that. Let's see. F filter SY17 ATH. Those are all still there. Oh, duh. I need to do it by experiment name. So that I want to group by EX name 2. And I want to, okay, I made the EX name 2. We need to do our left join by that as well. And there we are. We don't have the weird thing that we had there. So, all right, I will. All right, well, there's a number of challenges there that you've had to work through. And it looks like probably the best thing to do right now would just be go ahead and finish up with your R version of this assignment. And I would clean up the figures with some, or maybe make some figures, maybe just tables, whatever you think communicates just the best. And also, it's a little overwhelming to look at a table that has that many means or standard deviations or medians. So maybe using a little fewer of the groupings, or grouping by different variables, by soils, something like that. There could be a story to tell there. Really, this story gets a lot more interesting next week with linear regression.